So let's do an example for t-test. Statistics students believe that the mean score on the first statistics test is 65. A statistics instructor thinks that the mean score is 65. So he samples 10 statistics students to obtain the scores. So here's the scores: 65, 65, 70, 67, 66, 63, 68, 72, and 71. Okay, he's going to perform a hypothesis testing using a 5% level of significance. The data are assumed to be from the normal distribution. So they both believe the same thing. They believe it's 65. So we're going to test that. So which test should be used? A t-test, because the population standard deviation isn't known. We had nothing to believe that there was a population standard deviation. We were given a population mean, but we were not given the population standard deviation. So state the null and alternative hypothesis. This time I am going to start with the null. The mean does equal 65. The alternative is the mean doesn't equal 65. There was no directional pull in that. It didn't say that he believed it was less than or greater than, just that it was. Is this a right-tailed, left-tailed, or two-tailed? This is a two-tailed, and the reason it's a two-tailed is because of it's equal. So remember, if you're confused about that, go back to the PowerPoints or their videos and it'll show what the scenarios are. Is the population standard deviation known, and what is it? The population standard deviation is unknown, so I'll have to run a t-test. Okay, so this is how you do it in the calculator. So for t-test, you're always going to have, in this case, for this class, you're always going to have sample data. We did that just to kind of make it a little bit easier. You can have sample data in your z-test, but again, remember, for the t-test, the population standard deviation is unknown. So enter the data under stats, edit, and then L1. So I've entered my data, and then I'm going to go over to stats, test, and t-test. It's right under z-test, so make sure you don't get the two confused. So you're going to go to input, data, and you're going to choose data. You're going to do population mean, list is L1, frequency is 1, and you're going to choose the alternative hypothesis. Your output screen, you're going to get the alternative hypothesis again. Then you're going to get the t-test statistic, the p-value, the sample mean, the sample standard deviation, and the sample size. Hint, you're going to be asked for those on the homework and the practice problems, so there it is. You don't have to do it by hand. The calculator gives it to you. So here's an example of what we're looking for. Again, I put everything in from the last problem that we just did. That's what it looks like. And here's the output. So I get that the mean doesn't equal 65. The t-value is 1.978. The p-value is 0.079. The sample mean is 67. The sample standard deviation is 3.197. And the sample size is 10. Okay. For the website, it's a little bit trickier. So you're going to go to the www.socialscistatistics.com, go to the calculators, and you're going to do t-test calculator for single sample. You're going to make sure to enter your data in the sample box. To me, this is kind of easy because it's kind of a no-brainer. All you have to do is enter the sample data and then put your population mean. You choose your level of significance. For us, it's 0.05 for this one. Choose a one-tailed or a right-tailed test. Remember, if it's less than or greater than in your alternative, it's a one-tailed. If it's not equal, it's a two-tailed. So this is what it looks like for the problem that we're doing now. I put the population mean in, and I have my samples, and then I have 0.05 and two-tailed. And this is the output I get. I get the t-value equals 1.978. I get the p-value of 0.0792, and I get that it's not significant. I'm not going to look at that because I want to go do it a different way. So here we go. What was my test statistic? T equals 1.97. I got the same thing regardless of the calculator or the website. P-value is 0.079. All right, so as a preconceived alpha equals 0.05, what is your P versus alpha? So 0.079 is greater than 0.05. My decision, fail to reject the null. Why? P again was larger than the level of significance. So my conclusion, at the 5% level of significance, there's sufficient evidence to show that the mean test score is 65. So think about it. I said that the null hypothesis was true, so the mean test scores are 65. So everybody was right, but the average grade was 65.